Our special speaker that we have today is Professor Ahmed Elgemal. He's a professor in the Department of Computer Science at Rutgers University and also the founder of the Art and Artificial Intelligence Lab at Rutgers. So let us ask Professor Aligamal to maybe a little more introduce themselves and give us a little background and their talk. One thing that I wanted to mention is that his talk today is about the shape of the art history in the eyes of the machine. And I think that he has done many interesting work in the realm of understanding the patterns and the evolution of art through the history. Please go ahead. Thank you.
Thank you very much. Thank you for inviting me, and thank you everybody who is here. I'll start by answering a question you asked earlier about why I'm doing this, and I think it will be more also clear during the talk. Basically, during my high school years, I was raised up in Alexandria, Egypt, and when you're raised up in a country with all the history like that, you see a lot of archaeology and history and art, and I really wanted to study archaeology and art history. That was really my passion. But in the same time, computer science was something totally new at that time, and like around early 90s, and I was fascinated by it. And I had to choose a major. So everybody was telling me, if you go to archaeology, art history, you'll have no career and you're gonna make no money. And I went to study computer science, and for the last 25 years, I've been doing AI. But I found that actually my passion is really in art. Every time I go to a computer vision conference, I escape 90% of the conference and I go to galleries and museums rather than attending the sessions. And I realized I have to do something about it. And it will be clear in the talk basically how I moved into doing that and why I moved into doing that. So let me just start right away by sharing my screen. And so basically, as an AI researcher, when I look at images like that, I mean, will be very happy if the machine will recognize there's a man, there's a woman, there's a fruits, there's trees, there are trees and things like that, right? That's what we do in vision. And that have been doing for a long time also. However, basically, we realize that art, when you look at art, is much more than that. There are layers and layers of context, historical context, social context, understanding. There are emotions that happens. I mean, art is not about object recognition or anything like that, or scene recognition. It's much more. And since the ultimate goal of AI research is to make the machine, make machines that have perceptual, cognitive, and intellectual abilities similar to those of humans, I find that analysis of paintings, whatever the analysis means, involve actually all these tasks: perception, cognition, and intellectual abilities. And that's why I think it's very important to advance AI to look at art and try to understand art the same way human does. So basically, I find that the ability to understand and generate human-level creative products such as poetry, stories, jokes, music, paintings is fundamental to show that artificial intelligence algorithms are actually intelligent. And the first question that always been asked when I give talks, especially in humanities, with audience from humanities, is how to combine art and AI. Basically, isn't art is aesthetic judgment, which is subjective, and science is objective. How can this be combined? And that's a very important question. And actually, it's rooted in Western philosophy. Basically, Western philosophy has placed aesthetic comprehension in the realm of subjectivity. And we can trace that back to Immanuel Kant in 19th century, sorry, in 18th century, when in his book about critique of aesthetic judgment, when he explicitly argued that the judgment of taste is not cognitive judgment, it's not logical, but aesthetic, which means that it's one whose determinant ground cannot be other than subjective. And that actually shaped the separation between art and science in the last 2 centuries. So another quote here from Colin Martindale, who is a psychology professor at University of Maine, who has the totally different opposite point of view. As a scientist, I feel that if everything in the universe is governed by laws, then art history must be as well. So totally scientific approach. Basically, nothing is subjective. And another viewpoint from Eric Kendall, who's a neuroscientist and winner of a Nobel Prize, by examining perception of art as an interpretation of a sensory experience, scientific analysts can, in principle, describe how the brain perceive and respond to art. And let me go into basically he's saying, can any aspect of art which is creative and subjective experience be studied objectively? And finally, a quote from an art historian, which is very unusual art historian. His name is George Kubler, from his book, The Shape of Time, which I'm going to talk about in the talk a little bit later. He's saying basically that art history could prove to contain unexpected potentiality as a predictive science, which is very uncommon view within art history. So my goal is really to understand what are the implications of looking at art through the eyes of the machine. By that I mean AI in particular. That's why I started the AI lab about maybe 8 years ago at Rutgers, really focusing on advancing AI by looking at art and also seeing what can we do about art if we do AI. And here are some of my collaborators from art history, from fine art, and I've been blessed to work with many students from Rutgers and from other universities as well. And these are some of the activities that have been done through the years, many others, and these are some things I'm going to talk about today. Building models to understand art, style, genre, doing art classification, try to understand influences between artists, try to understand creativity, how to quantify creativity, how to generate art, how to understand the evolution of art history. Many things have been done during these years. But let me start by the basics, basically. So how artists talk about art. So if you look at an artwork like this amazing Renoir painting, basically artist doesn't look at this and tell you there are multiple people or people are eating food or things like that. Basically talk about, artists talk about elements of art, the space, the texture, the form, the shape, the color, things like that. Principles of art, the movement, the unity, the harmony, balance, contrast. Other topics like subject matter, brush strokes, meaning, historical context, social context. All these things are basically what artists talk about when talk about art. Their least concern is things like object or scene classification and things like that, or generating a caption. Our goal really was in the last few years is try to quantify each of these elements, and we have done a lot of work on quantifying each of these elements. How to do visual encoding of the image in order to be able to quantify these elements and principles of art. And in particular, one of the very, very important things in art is the topic of style. So what is style? So basically here, this is a depiction of the Last Supper. So basically the famous painting by Da Vinci, but Da Vinci's painting is just one of them. This is much earlier to version, many versions by many artists till 20th century versions. And really, and here you can see what is the meaning of style in one slide like that, where basically you're depicting the subject matter in totally different ways depending on historical point and what happened in art history that specify how the artist will depict the scene. And here's the first thing. I mean, if you look at this and what artists mean by style and compare that to what we in computer vision or AI do when you do things like style transfer and things like that, it's a rise. Basically, it's a joke that the way we do a style transfer in machine learning and computer vision, which is mainly basically meaning taking the palette from one image to another, or a texture from one image to another, has nothing to do with the concept of style in reality, because the concept of style is much more deeper than just these simple things. So the question really is what characterizes the sequence and evolution of art style change over time? How can we characterize these changes? And actually, what factors drive these changes of style over time? Why even artists change style over time? When that happens? What triggers it? And how to characterize it when it happens? Can we build computational models that can help answer these questions? So we started very early with a very simple thing, which is painting style classification. You have a bunch of images and you have style labels on them. So it's really a simple supervised machine learning problem. And you want to classify the painting to think classes like Renaissance, Baroque, Impressionism, Cubism, abstract, things like that. So very simple problem. And we take a painting, we have visual encoding using different features, trying to capture the low level, mid level, semantic level feature, which are parallel to different concepts of art, as I mentioned, and trying different machine learning techniques on them, and doing supervised learning to classify styles. And basically, these show progress over the years from the year 2012 till maybe 3 years ago, where we have been really trying any new things that happen in machine learning and see what it adds. Things from the time of bag of words and class me's and HOGs, if you really remember that, till the time of CNNs and deep learning. The number of style classes we have been basically increasing the number of classes over time, trying to get deeper. But basically, how to monitor the progress is compare it to random guess. How much better you can do than the random guess, starting from 4 times random guess to 12 times the random guess. So okay, and can do better than that. All right, so we do style classification. The machine can classify style at the level of maybe a first-year art history student. If you give it an artwork, it can tell you this is Cubism, this is Impressionism, this is Renaissance. Good, the machine can do that. So what? Why that's even important? So when I talk to art historian about machine classifying style, they ask me, so what? Why that's even important? Here is why I think it's important. Classifying style by the machine is not what interests art historian, but actually instead what the important is, what are that tell us about the characteristic of style and what drives style changes. And we know that if the machine can classify style successfully, that implies that the machine has learned some internal representation that encodes some features, some discriminative features through its visual analysis of these art. However, we also know that the machine uses visual features that's always very hard to interpret by humans. So especially if you're doing deep learning, it's very hard to interpret these visual features. So it's very hard to understand how the machine did classification of style to start with to get something useful. So we went into studying basically how the machine identifies style and if there are a relation between the way the machine internally represents style and the way art historian think about style. And for that, it's very important to look at how art historians look at style. Here, this is Heinrich Wölfflin, one of the founding father of art history, modern art history. He basically have a theory about style. In particular, he looked at how to separate the study of subject matter from the study of the visual form, which is style. And in his book, basically, he really studied the difference between Renaissance and Baroque. So in the top here is a Renaissance artwork, and in the bottom is a Baroque artwork. And he suggested basically some visual schema that you can tell the difference between Renaissance art and Baroque art. Basically, he mentioned 5 pairs of elements. For example, linear versus painterly. In Renaissance art, the contour, if you look at the contours, they are very sharp while in Baroque, it's very fuzzy contours. That's basically linear versus painterly. In Renaissance, all the subjects are in one plane, while in Baroque, there are depth in the scene. So this planar versus recessional. In Renaissance, everything seemed to be within the canvas, while in Baroque, basically you see like a cropped image from a bigger scene. So this is called closed form versus open form. In Baroque, in Renaissance, basically every subject by himself or by herself. So this multiplicity versus in Baroque, this unity here. You can see that all subjects are part of a unit, one unit. In Renaissance, it's everything has absolute clarity. All the scene, everything is in focus. While in Baroque, artists start to have relative clarity. There are depths, there are things that are in focus, things that are out of focus, depending on what the artist is trying to do. So he suggested that these 5 pairs is really what what make the difference between Renaissance and Baroque, and even went to say that basically these 5 pairs are the kind of feature that can classify any style. So any style variation really goes along these elements. However, this is very interesting. However, this is a theory in art history, which is what we call in math or science, basically a conjecture, not a theory, because there is no proof of that. How can we even prove these theories, especially if you want to generalize it to all styles? So what we did is we're trying to look at this internal representation of how the machine classifies style and draw the parallel to what Wolverine suggested. So what we did is basically we trained several models, several CNN models, and we keep doing that. So things like AlexNet when they appeared, VGGNet, ResNet, every CNN model that comes around, we try that as well. And the goal is basically to train the machine to do style classification in a supervised manner. But the goal is not to do the classification. The goal is to look at what has been learned here. So analyze the internal representation and do some statistical analysis and some visualization on top of that. So after the machine learned style with acceptable accuracy, we kind of start adding layers in the middle here to increase the interpretability of the representation. Basically, go down to as small as number of internal nodes as possible here to have more interpretable representation. Doing things like principal component analysis on the activation, source separation, ICA, looking at the manifolds of activations, doing correlation with time, correlation with Wolverine pairs, all these kind of analysis we have done to understand the representation. And here is really some of the results that we found. So this is the first thing that's very interesting. We used either pre-trained model on ImageNet that we fine-tune on art collection. We use wiki art collection, about 7,000 images in our studies. And by doing that, we reach accuracy of classification is about 60%, more or less, by all these networks. If you use a network from scratch, you can actually get 10% less, 50%, only on 77,000 images without the need to retrain on a million ImageNet. All right, so that's interesting. So we can get reasonable results even without any pre-training. But the interesting thing is this: looking at the filters that the machine learned, if you train from scratch on style, they look very different from the filter that you typically see in object recognition CNNs. You know, in object recognition CNNs, you always get these Gabor filters and this edge-like, oriented edge-like filters. If you look at how the machine look at style classification only, nothing like that. We don't see almost any edges. Maybe only one filter looks like a horizontal horizon or something like that. But other than that, it's very hard to interpret these filters. But definitely they are not edge-like filters, which will tell you if you want to classify style, there's nothing about object or composition that matters. There's something else, but what is it? We don't know. So this is one thing to keep in mind. Then the most important finding is that looking at activation of the internal layers, we find that a small number of factors can explain most of the variance in all art history that we studied. We look at mainly at Western art history over the last 500 years, just to be clear. We didn't include any Asian art or African art or other cultures. So between 6 and 10 factors can explain 95% of the variance in the data. And actually the first two modes of variations explain about 75% of the variance, depending on the network. So, and this is common in all the networks we have tried, whether it's AlexNet or complex networks like ResNet. You can see that 75% of variance, up to 75% of variance can only explain in the first two modes of variations. So what are these? So here, for example, we visualize a small set of maybe 1,700 images. Every image is a dot in this graph, and these are the first two modes of variation of the activation of the layers before the final layer. And here we color code them based on the time of the artwork. So what you see here is Renaissance art is here, and then Baroque art comes here, and then all the way 19th century, and all the way till Impressionism here. And then you can see what's happening in 20th century coming here, cubism and abstraction and pop art and things like that. That's amazing. Why that's amazing? Basically, the machine put art in an arrangement, in a chronological arrangement by itself, although we never tell the machine anything about when the art was made. The only information the machine sees is the image and the style label. We don't tell the machine that Renaissance happened before Baroque, or Baroque happened before Impressionism, or anything like that. But the machine, to learn to classify style by itself, has to make the arrangements, the correct historical arrangement of artworks. So we find that basically there is a 0.7 correlation coefficient with time if you go clockwise in this graph here. And each of these axes, there is also a high correlation with time as well. So that's very interesting. So the machine basically, why that's important? Because that's important because that actually resonates with one of Wolflin theories, which is, he said basically that style change in a smooth way over time, exactly like a rock rolling down a hill. That's basically his metaphor. And that's what we see here, that the machine find out that in order to understand this concept of style, it had to put the art in order historically, although we didn't give any historical context, but it really find that by itself. So that really confirmed that styles are not just bins that are classification classes that are isolated. It's smooth transition between them. This is one of the very important things. And this is common in all representation. If you look at any of the networks that we looked at, whether it's pre-trained or trained from scratch, you can find this high correlation with time in the representation. And as I mentioned, basically this is confirm Heinrich Wolflin conjecture about that. So the question now is, what are these two factors that explain 75% of what happened in art history? If you look at this and try to interpret it, it's very hard to really find one interpretation. People can have different interpretations. But we look at basically how these axes correlate with the 5 pairs that I mentioned by Wolflin, Benterly versus linear, recessional versus planar, things like that. And we find that in all the time, the first mode of variation, the most important mode of variation, is being recessional versus planar. And the second, all the time, the second most important mode of variation is correlated the most with linear versus Bentley. And that give us a very nice way to look at what happened in art history over the last 500 years. So basically what happened is, here at Renaissance time, art was totally planar and basically linear. All the contour was linear and sharp. And came Renaissance, came Baroque, and things start to be recessional, depth, and art becomes painterly, and the contour become fuzzy. All the way to Impressionism, where that's the ultimate painterly experience. In Impressionism, all the strokes are just fuzzy and you don't see any contours. So this is the ultimate painterly experience. But you can see that you still have depth, artists looking at scenes and things are still recessional. And then came Cézanne and came 20th century art, where basically things become flat. Artists start flattening the canvas again and becoming to be planar again, like Renaissance. And basically most of 20th century is in the planar sides of things, but coming to be linear again. So if you look at pop art like Warhol or abstract art, you can find that arts become linear again in the contours. So basically art history went into a full 360-degree cycle over the last 500 years in Western civilization, which really captured by this one diagram that really came from the representation the machine learned from looking at art style. And again, some other interesting things that we found in this representation, if you look at two of the modes of variation, I think this is the 5th and 6th, or maybe 4th and 5th modes of variation. This is the one that correlates more with the discrimination between Renaissance and Baroque. So you can see Baroque in the top here and Renaissance in the bottom here. And you can see that basically these two factors are correlated the most with the pairs of Wolverine. So basically, Wolverine was correct in suggesting that these pairs are a good way to discriminate between Renaissance and Baroque. However, we also found that he's not correct when he said that this can tell the difference between all other styles. All other styles basically are spanned by these five factors, because we find that we cannot tell the difference between Impressionism and Post-Impressionism by looking at any of these factors. There is none of them correlate with this discrimination. Another very interesting thing that we find is when we look at the activation manifolds of these networks, the internal representation of this network, we look at the activation manifolds. And again, here we're visualizing different artworks based on their time of creation from 1400 till 2000. You can see also the movement of art history and how things have changed. And you can find interesting connections. So you can see basically Renaissance here, moving into Baroque, moving into Neoclassicism in 19th century, moving into Realism, and then moving into Impressionism here. And from Impressionism, basically Post-Impressionism went in two directions. One direction that go to Expressionism, and one direction went to abstraction. So you can see Cubism and abstraction here. So that really tells us much about what happened in art history, and we find very interesting things when we look at this. For example, if you look at this figure here, look at this connection between Impressionism and what happened after. And if you look carefully here, we find that this connection is mainly Cézanne's work. So all the circled artwork here are work by Cézanne. So at the bottom here, you can find Impressionism, and that's Cézanne, and that connect to abstraction and Cubism. So that's interesting. So you can see here Cubism and abstraction in the early 20th century happening after Cézanne. Here's another representation where really here is Cézanne work, and this is Impressionism, and basically this is Cubism, Picasso and Grace and other Cubists. And you can see how Cézanne's connection here, making the connection between Impressionism moving into 20th century and how special his artwork. And you can see that in the data, you can even touch it. You can see how Cézanne is a bridge here. And the interesting thing is that obviously being a naive person when it comes to art history, I always go to Wikipedia when I learn about something. When I go to Wikipedia learning more about Cézanne, I found this interesting quote. Cézanne is said to have formed the bridge between 19th century Impressionism and 20th century's artistic inquiries in Cubism, and both Matisse and Picasso are said to have remarked Cézanne as their father, basically. And that's very interesting, because this is not only a metaphor, like bridge here is not a metaphor like in art history, but actually it's something that you can almost touch in the data, in the visualization. You see how Cézanne is really connecting this. Not only that, but I mean, another interesting thing here, if you look at this manifold representation, you can see many artworks here are Renaissance artworks that are pulled away from the Renaissance crowd, because the way manifold learning work. In manifold learning, you're building a graph connecting all nodes, and you do embedding of that graph. So you see here that these Renaissance paintings are embedded away from Renaissance. When we look carefully about this, we find that basically there are particular artists that keep appearing again and again here. In particular, we find El Greco and Durer, the German artist. So it's clearly that El Greco and Durer has influenced modern art, and many modern artists have really influenced by them. And that's very clear in the case of El Greco, because of the way he drew in a very deformed way, which really affected Expressionism and even Cubism. And that's very clear here, why you see El Greco work pulled away from Renaissance, close to modernity, modern art. In Durer, it's very hard to understand really how Durer influenced modern art history, but also Durer is very well known that he's influenced art history in the 20th century, but not clear exactly how. That's very interesting. All these tell us about how to characterize style changes, but let's dig deeper into that. And our work that I'm going to talk about now, back from 2014, 6 years ago, was about quantifying creativity in art networks. How can we quantify creativity in art? And you will understand in a little bit how that relates to style changes, how that characterize style changes as well. So basically, we wanted to develop algorithm that assess creativity of a painting given its context in art history. That might seem to be a silly question for some people, but I think it's very important. Because if you want to build creative agents that's able, it has to have its ability to assess creativity by itself. Because at this point, till this point, when machine create art or music, it's always the human that assess creativity of this machine. We do human subject studies, we give it to judges, things like that. But can the machine on one day be able to assess its own creativity? And for that, we need to develop this algorithm to quantify creativity. But that leads us to question, what's creativity to start with? How can we define creativity in a way that's quantifiable? So there is a historically long and ongoing debate on how to define creativity. We can describe a person to be creative, like Mozart is creative, or Warhol is creative. Or we can describe a product to be creative. So you can say, for example, the Mona Lisa was a creative artwork. Or some people prefer to characterize the mental process to be creative. So there are different ways to describe creativity. We focus on novelty of product in particular, whether something is creative or not. So how can we do that in an objective way? So it seems to be there are two main conditions for some product to be called creative. This product has to be novel compared to prior work, but also has to be of some value, so people take note of it and become influential, which is exactly like what happened in scientific community when you write a paper, right? I mean, you have to be novel compared to prior research, and it doesn't make a difference if nobody cites your work, right? So basically, that tells us it's not influential and not that creative. This is a quote from a very good book, which is a collection of essays about creativity, which basically concluded that although there are three different ways to define creativity, these are the most common essence of what creativity is. And that actually relates back to Kant philosophy. If you go to Kant philosophy, he defined 5 elements of what he called artistic genius. And the very first 2 of them is originality. The originality must be its primary characteristic, and influence. Its product must at the same time be modeled or exemplary. So other artists would start to get influenced by that. So these are the 2 fundamental reasons behind what he called artistic genius or creativity. Let's move forward to the 20th century. One person in the audience asked a question referring to Margaret Boden. So Margaret Boden suggested basically 2 distinct notions of creativity: the psychological creativity or B creativity, which assesses the novelty of idea with respect to its creator, versus historical creativity, which is assessing the novelty with respect to the whole human history. Is what I'm creating valuable and novel compared to all what happened in history? So this is the subjective. This is the objective measure. The psychological creativity is more of a subjective measure, but historical creativity is an objective measure. So basically, that's what we're trying to do. We're trying to align ourselves with historical creativity of product and try to define an algorithm to do that. So we propose an algorithm to assess creativity that's basically unsupervised, meaning that we don't have any creativity labels. We just have a bunch of artworks, and the only information I'm going to have is the date that artwork was done. So these are two information: the image and the date, nothing else. And we're trying to infer from that something about creativity. Some fundamental issues we have to think about before even we start deriving any algorithm about creativity, because these are common problems. These are common problems that will face any algorithm that will look at creativity. Suppose you have an algorithm that assesses creativity. That algorithm looking at an artwork and try to judge whether it's creative or not. Obviously, that cannot be done in a vacuum. The algorithm has to look at the context of that art history, to judge, right? So this one limitation that the algorithm only see a part of art history, whatever digitized, whatever reach us and digitized and available as a data set, right? So that's one problem. So these are closed, what I call the closed world limitation. And then the algorithm look at the art through some visual encoding, which also add limitation. So there are some concepts and elements of art that are being quantified here through these visual features, and there are others that might not. So that's basically another limitation, which I call the artistic concept quantification limitation. And then any algorithm has parameters, and these parameters will influence the output. So we can get different results by changing the parameters. So how can we make use of that? However, these are all limitations that should not stop us, because first the closed world limitation will always go away. We have more and more art being digitized and more data we can get. So this will go away. We have advances every day in visual encoding, and we become less blind and have better encoding. And the parameters actually are not a limitation, because the parameters actually we can really give creativity scores and understand exactly how the parameters affect the scores in a way to understand what we are measuring. Are we measuring creativity based on certain settings related to composition, or are you measuring it related to brush stroke work or color? So all that allow us to a rich way to understand creativity. So the bottom line is we want to derive an algorithm that look at art pieces, images, and their timestamp, and give us a score. So that's basically the input and output. And let's, what we do is that we start creating a directed graph between all paintings in our collection, where there is an edge between each two paintings with a weight reflecting the visual similarity according to the visual encoding that we are using, how similar these two paintings are. And it's directed based on the time, basically, if BI comes before BJ, so it's directed in that way. And now let's think about a simple inference we can do. Suppose you look at these two arts, Caravaggio from 1602 and a less known artist from 1800, almost 200 years later. If you look at these two artworks side by side, you can realize basically that this second artwork is very close to that in terms of body pose, in terms of light, in terms of composition, subject matter, everything's very similar, right? So it's clear that that work is a derivative of Caravaggio. So on one sense, that artwork is not as novel compared to Caravaggio. And in another sense, Caravaggio has an influence in a direct or indirect way to that artist. So high similarity between two artworks in the network imply that creativity of the earlier work has to go up, and creativity of the later artwork has to go down. These go down because it's derivative, and these go up because it's influential, at least on these two pairs. Compared to another case like that, this Alfred Sisley from 1883, and this Picasso from maybe 20 years later from 1907. They are very different, had nothing to do with each other. Different ways of using color, composition, totally different, right? So very little similarity between them across, depending on the feature you are looking for, but still very low similarity. And that implied that Sisley was not influential on Picasso, at least in a direct way. And Picasso was basically novel in making that art compared to this work. So that low similarity implies lower creativity for that artwork by Sisley and higher creativity for that work by Picasso. So if you take these two elements of inference and start building a formulation for creativity, what you can do, you can write down a formulation like that, where the creativity of any node can be described as the creativity of all nodes connected to it. In this formula here, alpha is a factor that indicates the probability that the similarity between painting can be just a coincidence. And the way to interpret this formula is like that. Any node in the graph collects influence from all its outgoing connection in this summation here. And for any node in the graph, it distributes its creativity tokens among all incoming connections. So you reach this formula that you can write, where this formula actually, if you look at it, it's basically an instance of what's called network centrality problems. So you can see how many other algorithms are special cases for of this, or these are special cases of others. So you can think of this as a random walk in a Markov chain. If you set alpha to be 1, this term will vanish, and you have this term only, which is called basically eigenvector centrality. You can think of it as a weighted variant of Hubel centrality, if you're familiar with this body of work, basically network centrality. But basically, network centrality is very fundamental in studying social networks these days, in studying pandemics, propagation, things like that. Even in the PageRank algorithm by Google is basically a network centrality problem. And you can think of this formulation as basically inverted weighted variant of PageRank. We can even extend this in a way to separate originality from influence. So we can see that basically originality can be controlled by another parameter. Here, you can measure originality or can measure influence in particular. So the question is, how can you even evaluate that? If everything is so unsupervised here, we don't have any creativity labels. We can show results to 10 art historians. Everybody will have different opinions. So how can we even evaluate this algorithm? We worked on different datasets, the WikiR datasets, and something called archive datasets, much older. And at that time, we did this work on 2014. And at that time, this is the art in computer vision was mainly things like jest and bag of words and things like that. And that was very excellent because we really wanted to use features that are not trained on art at all. So these are off-the-shelf features. ClassMe, it was a feature that basically encode object representation in images. So it's a very good way to encode subject matter in particular. Just come from MIT, basically comes from MIT, which encode texture and other things related to object and scene classification. So we thought that these two features are very useful. They are not trained on art. They are generic. They capture things that we can relate to in art, whether subject matter or brush strokes or scene composition. So let's use them and try to make sense of the result based on that. So here's one chart that shows basically time on the x-axis from 1500 till 2000, and every artwork here is plotted with its creativity score. So the higher the score, the y-axis is the creativity score. And you have to remember that the formulation is a 0-1 game, meaning that if some artwork, if you give it a set of artworks, the sum has to be constant. So for some artwork to score high, another artwork has to score low. Everything that we give to the algorithm are masterpieces of artwork anyway. So nothing here is really scrambled by somebody in the street. All these are masterpieces. But the way to look at and interpret this, since we are using in particular ClassMe, and just we are really trying to look at creativity with respect to subject matter. How creative were artists in depicting the subject matter over time? So you can see, for example, what scores low in 19th centuries is art by the amazing artist, French artist Ingres. Why this scored low? Because basically, according to subject matter, there's nothing really innovative about having a portrait of a woman in 19th century, because this has been done a lot in Renaissance and Baroque all the time. So subject matter here was not really novel. While in the same time, what scored very high was things like Munch, The Scream, or Monet, Haystack, very early version of that, and others. So when we look carefully on the 100 years from 1850 to 1950, when we have a lot of data digitized and a lot of artwork, we can find that the machine makes sense a lot about what happened in art history in that time. So you can see the machine identifying things like Munch, The Scream, giving very high score, Klimt poster, things like cubism and things like that. So that makes sense. Here, deeper into that. If you look at the first 10 years of 20th century, the highest scoring artwork, for example, is Picasso, Ladies of Avignon. I didn't know much about that artwork other than I like it, but I didn't know much about its history. at that time. But when I look at its history, I find that art historian now agrees that basically this artwork was the beginning of Cubism, very early, even before Cubism became a thing. And what you see in this graph here, the machine gives this a very high score, and what's topping that in 1912 is actually Cubism itself. So these are artworks when basically in the very early Cubism exhibitions by Picasso and Braque. And you can see here that before that, that was the highest scoring one, and this is topping that. What's topping that even more in 1915, artwork by Malevich, what's called Supremist art movement, which is totally abstraction in 1915. That's topping even Cubism. Okay, anyway, all that's nice, but how can we even say that it works or not? It's all anecdotal evidence, right? So, I mean, here is something very interesting. What was that artwork that giving very high score in that chart here? And when you look at carefully at that artwork in particular, you find it's an artwork by Mondrian that was dated in our dataset to be 1910. And that was very interesting. Obviously, when you find something like that, you have to look at it and see why this is scoring very high. And I find something very interesting, that basically Mondrian didn't paint this in 1910. Mondrian painted this in 1932, I guess, I remember. So that was a mistake in the data set. So the data set itself has something wrong that would say basically Mondrian painted that in 1910. And if Mondrian would have painted that in 1910, that would have been even before Cubism, before abstraction, and would have been the most creative artist in his time. But obviously that's not. But that mistake actually gave us a very interesting idea about how to even evaluate this. So there are many results here. I'm going to skip that. And the way we evaluate this is what's called art time machine. So what the idea is this very, very, very simple idea that comes from this mistake in the dating of that artwork. So what happens if you take an artwork from Baroque or Renaissance and move it forward in time and change its date to, let's say, 19th century or 20th century? What do you expect? If the algorithm works, that the creativity of score for that artwork has to go down, because if you create a Renaissance artwork in 19th century, you are not creative. In the same time, if you take an artwork from 19th century or 20th century and move it back to 1400 or 1500, you expect its creative score to be going very up, because it would have been very different from what happened in that time and very early influence to what happened much later. So you expect its creativity score to go up. And that's what we did. So what we did is basically we did many experiments where we take only 10 artworks, change their timestamp randomly, either moving them backward to 1600 from modern schools, or moving forward to 1900 for Renaissance and Baroque, or basically as a baseline, just move them around 1600 randomly. We basically find that that's an interesting part. If you move forward Renaissance and Baroque artwork to 19th century, you can see consistent drop of creativity by 8 to 10%. So it's consistent when we repeated these experiments. If you move modern artwork from 19th and 20th century back to 1600, you can see that the creativity score increase. However, with varying degrees depending on the art movement, and that makes a lot of sense. For example, if you're looking at expressionism or cubism or post-impressionism, you can find a huge increase in creativity if you move them back to 1600. Compared to neoclassicism, neoclassicism basically is a reinvention of Renaissance in 19th century. So if you move it back to 1600, you have only a 5% increase compared to 16% increase for post-impressionism. So that right away tells us basically the algorithm is really doing something making sense in terms of quantifying creativity and giving a score that really captures the novelty and influence that we're looking for. When I showed these results to my art historian collaborator, Maria Mazzoni at the College of Charleston, she was interested in the result and gave me this book, basically, A Shape of Art History, which I quoted from in the beginning by George Kubler, who's an art historian. And in this book, basically, Kubler had a theory about how art history evolved. So basically, he's saying that artists copy ideas from each other all the time. That's what happened all the time within a style, until basically some artists come and makes some artwork that is really different for some reason, and that what he called primary objects really give birth to a new style. And if other artists start to taking note of that and start replicating this new style, that becomes a new style. So basically, he focused on this concept of prime object, which are iconic artwork, and replica mass as a process that really drive style moving forward within a style. And I even find very interesting quotes in his book that say basically primary objects here. Primary objects resemble prime numbers of mathematics because no conclusive rules is known to govern the appearance of either, although such a rule may some be found. So basically, this is a very amazing analogy. He makes the analogy between these prime objects in art history and prime numbers. They are prime numbers cannot be divided by a number before them, but they divide many numbers that comes after them. And that analogy is really get me thinking about the algorithm that I just described, the graph inference algorithm. If we construct this graph and the nodes are numbers and the arrows are divisibility, the algorithm basically will give you a high score to prime numbers by definition. By construction, you find that the algorithm will give high score to prime numbers. So really, he's very, very correct in this analogy that prime object is actually very similar to the concept of prime numbers. And what we're actually doing in this network by giving creativity score, we are identifying what are the prime objects in art history, things like Munch the Scream or Picasso's Ladies Avignon. So when art historian tell us that this artwork is major, or where basically the population think of Munch the Scream or Monet's his tag as really a masterpiece, this is totally not subjective. There is some unconscious reasons for that. And this can be quantified by these kind of networks. And they are really a changing moment in history where something totally different happened and artists start taking notice. So because of the sake of time, I just want to go very fast toward the next topic, which I'll try to finish in 2 minutes, which is basically how can we actually use AI to generate art? And if the machine generate images, would that be considered art or not? These are very big topic, and I know that other speakers in this series will talk about that in detail. Aaron is going to be speaking, or maybe has spoken already in this series. But basically, our work from 3 years ago called Creative Adversarial Network which basically we try to make a variant of GAN that was new at that time to really generate a novel art. We call it generating art by deviating from style norm, by learning about style and deviating from style norm. These are some of the art that this network is generating. So basically, we wanna here's the story. Obviously, the audience here know deep learning and know GANs and know how they work. I don't have to go through that. And for example, GANs have been very successful in generating these images of bedrooms and other data sets. Very interesting things like that. So one question would be, what happens if you train GANs on art images? Suppose you give it art history images and you train GANs on that. Would it generate art? And actually, there was some trials in the early days of GANs where people train it on portraits and still lifes and things like that. However, there is a fundamental problem. The generator in GAN is trained to generate samples that fools the discriminator to believe they are coming from the same distribution as the inputs. So that's basically, we can think of a Chinese room problem here. So imagine the generator have access to actual images and can cheat. So you can take actual images of art and just generate it right away and give it to the discriminator. So actually, the discriminator this way can be fooled right away that thinking generating these artworks. However, this is basically the Chinese room problem. So there is no motivation for the generator actually to generate anything that's creative. The generator is just trying to generate something from the same distribution. The only creativity it can do is just generate something that was not generated before from the distribution. But that's basically, if we give it artworks of portraits, it will just generate some different portrait, but still a portrait that's very similar to what it sees. There is no force that push GAN to be creative. How can you change that? There is some background here that I have to go very fast over, coming from the theory of aesthetic evolution in psychology. Basically, this theory in one slide say that artists, if artists keep making the same kind of art all the time, like if artists in Renaissance keep doing the same kind of Renaissance all the time, because of habituation, we get bored of that, as the viewer get bored of that. And that becomes not exciting for the artist, not exciting for the critic, not exciting for the viewer anymore. So artist has to innovate all the time to push against habituation. However, if artists innovate too much, if artists, imagine Picasso did that in Renaissance time, or even when he did that in 20th century, that's too shocking. That people will not like that. And people actually didn't like that. Most people till now didn't like that. Because basically, according to what's called the Von curve in psychology, too much arousal relates to negative hedonics. Basically, people start to unlike what they see. So in one sense, artists have to push against habituation in what's called basically least effort. So artists really have to really push the envelope with a minimum amount to push against habituation without falling into the negative part of that curve. So that's basically the concept that we're trying to push. How can we push the network to be innovative, but keep it within the same distribution, push the boundaries, basically. So the way we did it is basically, in particular, we're trying to go out of the style by increasing style ambiguity. So the network here is a GAN. We still have the real, false, real, fake loss, which is in that case art or not art, because it's training on art. Then the network has a style classification. The discriminator also learn about style and try to classify styles. We give it style labels. And we added style ambiguity loss, which basically means that the discriminator was trying to see if the art as a generator fits within styles or ambiguous in terms of classifying style. And we're trying to basically maximize style ambiguity and at the same time minimizing the typical loss in real fake formulation. So basically, this is the loss, and we have art or not art. We have style classification loss, and we have this style ambiguity, which I think is very essential because this style ambiguity pushes against art not art. Art not art loss, typical GAN loss, will try to push things into the distribution, and style ambiguity will try to push things away from distribution, but keeping that will pull it back. So this dilemma between this opposite objective really pushes the machine to try to explore the boundary. And that's why we started getting this very interesting artwork that have very nice composition. Here we train the machine on art history from the last 500 years of art history, all subject matter, all style. We didn't do any curation. The goal is if the machine see all that art, what will generate? Will generate similar artworks or something novel. And the interesting thing, most of the things time a machine generates actually abstract artwork. Didn't give us much portraits or landscape, mainly abstract. And that was a very interesting question. If we remove the style loss, the style ambiguity loss, these what kind of things you can get, which are basically things that looks like mainly a repetition of art history. A machine here, again, is just basically trying to generate things that looks like the distribution. Adding style ambiguity, totally different results. Trying to, you can see it keep the aesthetic, it learned the aesthetics, trying to keep it to be in the distribution of what's appealing, but trying to come up with new compositions, new combination of colors, new interesting things. And We did a lot of experiments. There is not much time to go over them in details, but here is the conclusion. When we showed this to a human subject, combined with artwork from Art Basel 2016, which is a flagship art fair in contemporary artists, and also combined with another set of abstract expressionist famous artworks as a baseline. And to our surprise, basically, human subject thought art done by Can, the machine, basically, as done by human 75% of the time, compared to 85% of the time for the case of abstract expression, and only 48% of the time for art from the Art Basel collection. This doesn't say anything about creativity of the art. It's basically a Turing test to tell whether a human can tell whether that art is made by a human or by GAN. And at that time, basically, most art that is done by GAN has this uncanny look that right away you can tell it's GAN. It's deformed portraits, deformed, so you can tell it's a machine. But for CAN work, people cannot tell the difference. It's give it these high scores, and moreover, they give it describe it by words like intentional, has compositional rules, has communication, inspirational, give it high score in all these aspects, the same as art made by human. One last thing is why it works, why style ambiguity work. And that connects to what I talked about earlier. It is not bias of the data. Some people argue because maybe you have less abstract artwork in your collection, that's why it's generating abstract. And it is not, because all the schools here are we combine them into bins to make them uniform. So according to our laws, if these are distribution and this is the styles, there are plenty of room in between to create something that belongs to art and doesn't belong to styles, right? The machine tried to find out these spaces. However, if you look at this figure from before, that's Renaissance, Baroque, Impressionism, Realism, and things like that. You can see that there's no place in art history. Everything has been moving smoothly. And if you want to move forward, obviously this two-dimension block here, but the space is much bigger. If we really move forward, you cannot really create something just between Renaissance and Baroque. You have really push the trajectory forward, not insert something in between. And that's exactly why it works. So, and that's why it tends to generate more abstract than more uncanny repetition of the past, because it's figured out basically in the 19th century, things are moving in that direction, and there are more space to creating abstract artworks and surreal artworks without having to go and creating portraits and battlefield and landscapes that Discrimination can tell right away it's Renaissance and Baroque. So that's at least our understanding at this point. Anyway, I'll have to stop here because I went over time. I'm very sorry about that. The conclusion is we just scratched the surface. These are not a lot to discover in art history by looking at art at a macro level using data science and AI. And also there are a lot to be discovered by trying to boost the AI to be creative. Thank you very much.
Thank you very much, Professor Elgemal. It was very interesting discussion and analysis over history of art. I really appreciate that. I think that if anyone has any question, otherwise, excellent.
I think it was very interesting. I liked hearing about all of the art history and then relating it to the computer science aspects.
Thank you. I hope this was not boring from that aspect.
It was very interesting, especially trying to quantify creativity was interesting and kind of related to the previous talk as well.
I also find it very important that there is a separation between science and humanities. What we are doing in computer vision and if you talk about being creative and doing machine creativity, and you are disconnected from what's happening in art history or visual art history, we are making a big mistake. As I said, I mean, for example, the concept of style transfer in vision and machine learning totally nonsense when it comes to artists and it comes to artists. And we still keep doing that. We find like hundreds and hundreds of papers come every year about style transfer, which keep doing the same thing, which is totally nonsense to me, because that's not style and that's not what interests artists and what interests art historians. So this disconnect is really not good.
Thank you so much for sharing your interest with us. I think that this is very intriguing for anyone in the class who wants to, including myself, who wants to, explore more in this direction. So I appreciate your time and talk. Thank you so much. Okay, I think that we can stop the video now. Thank you. Okay, have a good time.
You too. Thank you very much. Bye.